Guys, so in this section 5.2 we are going to focus on the rational functions and graph. And on this problem number 1, match the rational function in column 1 with the appropriate description in the column number 2. So when I look at the function, rational function, if I study the denominator, I know that my denominator x plus 1 cannot be equal to 0. That means that x cannot be equal to negative 1. That implies that at x equal negative 1, you got a vertical asymptote. And that will correspond to the answer D. Problem number 4. On the problem number 4, we have f of x equal negative 3 plus x squared over x squared. And the question is, what could we do? So the first thing is, again, we could study the denominator and say x squared cannot be equal to 0, so x cannot be equal to 0. And so we could say that imply that at x equals 0, I got a vertical asymptote. But it's not suggested in the set of answers. So what I may want to do is transform my function f of x equal and say, hey, maybe I could have a x squared minus 3 over x squared. Why do I do that? Because when I study the division of two function, I always said if I want to divide my numerator by my denominator, I need to have the decreasing exponent. And when I say that, I realize that basically what I have is f of x equal x squared over x squared minus 3 over x squared. And so that means that my function f of x can be written as negative 3 over x squared plus 1. And what does that mean? That means that my function f of x presents also at y equal 1 an horizontal asymptote. And so I look at my system and I do not see y equal 1 a horizontal asymptote. But now when I pay really attention, they are presenting the fact that x equals 0, vertical asymptote. Where is x equals 0? X equals 0 correspond to y as the axis. Y axis is the vertical asymptote. So here we are. We got it from the beginning. And sometimes it can happen that we don't see that right away. And so the answer for the problem number 4 was H. All right, so now we need to do problem number 7 and 9. So problem number 7, what do we have? On the problem number 7, we got the function f of x equal x squared plus 3x plus 4 divided by x minus 5. So the first thing I want to do is, yes, I could look at x minus 5 cannot be equal to 0, and so x cannot be equal to 5, and so therefore that implies that at x equal 5, I got a vertical asymptote. But among the answers, I don't have that. So the second thing I want to do is try to do the division and try to express f of x in another way. And basically what I want to do is x minus 5 divide x squared plus 3x plus 4. I have a decreasing exponent, so I'm going to do a synthetic division. And if I do the synthetic division, I'm going to rewrite just the coefficients. And I'm going to bring down the 1 because I'm taking what I see. I had negative 5, so I'm taking negative 5. Because I'm taking what I see, I'm going to subtract. Negative 5 by 1 will give you negative 5. That will give you negative 5. But because of the minus, this negative 5 will become a plus. And so now I got an 8. Negative 5 by 8 will give negative 40. Because of the negative, that become a plus. And so I end up to have 44. So therefore, my function f of x, which was x squared plus 3x plus 4 divided by x minus 5, end up to be x plus 8 plus 44 divided by x minus 5. And so that is telling me that the function right here, x plus 8, is now an oblique asymptote. Why is it oblique asymptote? Because this is the equation of a line. Because this is the equation of a line, slope m equal 1, y-intercept 0, 8. So from the y-intercept 0, 8, I will have to go up 1, right 1, and so my line will go up. And so obviously, this is oblique. If it was going down, it will be also oblique. In that case, it's going up. So the answer for the problem number 9, for the problem number 7, was F. Problem number 9. All right, so in this problem number 9, what are we dealing with? Give the equation of any vertical, horizontal, or oblique asymptote. So when we're having f of x equal 3 over x minus 5, we can naturally put plus 0. So that implies that y equals 0 is a horizontal asymptote. And then because x minus 5 cannot be equal to 0, x cannot be equal to plus 5, and that implies that x equals 5 will be the vertical asymptote. There is no oblique asymptote in that case. Problem number what? 15 and 19. So, in this problem number 15, what do we have? We have a function f of x. This function f of x is equal to x squared minus 2x minus 3. And we are dividing it by 2x squared minus x minus 10. So the first thing I want to do is use Desmos. I use my graphic calculator. So if I go to my graphic calculator right here, and I graph x squared minus 2x minus 3 divided by 2x squared minus x minus 10, I can see clearly a horizontal asymptote. I see two vertical asymptotes. I see one vertical asymptote right here. I hope you can see at x equal -2, you got a vertical asymptote. You got a vertical asymptote a little bit after 2 and between 2 and 3. So you got a pretty good idea of what you are dealing with right now. All right, so the first thing I want to do is study my denominator. And my denominator cannot be equal to 0. And I can see clearly that I have if I want to find the value of x that could make this 2x squared minus x minus 10 equal to 0, I basically need to study 2x squared minus x minus 10 equals 0. I am going to add a plus right here and a plus right there, making reference as at ax squared plus bx plus c equals 0. That helped me to use x equal -b plus or minus the square root of b squared minus 4ac divided by 2a. And pretty easy to find a equal to, b equal -1, and c equal -10. Therefore, x is going to be equal to -1, -1. This is negative b equal -1, so -1, plus or minus the square root of -1 square. Every time I'm dealing with a negative number, I'm using parentheses. Minus 4 times a is positive, no need parentheses, but c is negative, so times -10. Divided by 2 times a, so divided by 2 times 2. So I continue, and I got x equal 1 plus or minus, and I got 1. Minus 4 by minus 10 give you plus 40. 40 multiplied by 2 is plus 80 divided by 4. So I end up to have two values of x. X equal 1 plus 9 divided by 4, which is 10 divided by 4, so x equal 5 over 2. And x equal 1 minus 9 divided by 4, which is -8 divided by 4, which is -2. So why 9? Because 80 plus 1 is 81, and when you take the square root of 81, you got 9. So basically, I'm finding that x equal 5/2 and x equal -2 are the vertical asymptote. So let's go back to my expression right here, and let's try to plug x equal 5 divided by 2, and I can see my vertical asymptote. And let's try to do another one, like x equal -2, x equal -2. Hopefully it will work. And you just saw that x equal -2, you got a vertical asymptote. So in order to find the horizontal asymptote, what I want to do is divide by the variable of the greatest degree, which is x squared. So I'm going to divide by x squared everywhere. And I'm going to divide by x squared everywhere. And so I end up to have 1 minus 2 over x minus 3 over x squared on the top, and 2 minus 1 over x minus 10 over x squared on the bottom. When I look at x going toward the infinity, the value of infinity, I can see clearly that 2 over x, but also 3 over x squared, or 1 over x, or 10 over x squared, will all approach to 0. So basically what I have is 1 minus 0 over 2 minus 0 minus 0. And so I end up to say that I have an horizontal asymptote at y equal 1 over 2. That would be my horizontal asymptote. So if I go back to my, and I'm going to increase, because I just realized when I view I cannot unfortunately show you the side of this screen because it's already set up. But let's see if I can plug y equal, and I'm going to do 0.5, which is 1 over 2, and I have my horizontal asymptote. All right, guys. So let's move on to the next problem, and this one was very interesting. So the first thing I want to do is, first of all, remember that x plus 3 cannot be equal to 0, so x cannot be equal to -3. Therefore, I end up to say that x equal -3 will be the vertical asymptote. That said, if I want to find maybe the other asymptote, what I want to do is do the synthetic division. And so for that, I'm going to take what I see, which is a plus 3. I have a decreasing exponent, 1, -2, and then plus 3. I'm bringing down the 1 because I'm taking what I see from my long division. That means I will have to subtract 3 times 1 equals 3. And the plus that is right here is going to become a minus. I had a plus 3, and now this plus 3 becomes a minus. So I end up to have a -5. Then plus 3 times -5 equals -15. The negative becomes a plus this time. And so I end up to have plus 18. Therefore, my function f of x can be written as x minus 5 plus 18 over x plus 3. And so very nicely now we can say that this is the expression of a oblique asymptote. And this oblique asymptote, why? Because this the equation of a line x minus 5, slope m equal 1, and the y-intercept 0, -5. All right, so I think we're good to go. I'm going to try to graph that function on Desmos, and then I will be done. All right, guys, so in black, you have the function f of x, x minus 5 plus 18 divided by x plus 3. In red, you have the oblique asymptote x equal -5 that we found, and we can see that it's an asymptote, and x equal -3 is the vertical asymptote that we have looked for when we studied the denominator. So I'm going to continue a second part for this section 5.2 to cover pretty much everything. All right, let me show you back again, and thank you.